Hi, third graders. Welcome to another virtual math lesson. I'm really excited to be teaching all of you, and especially excited because now I get to also be teaching both my kiddos and Miss Quinn's class. So now I get to kind of work with all of you, which is so exciting. So today for math, we're going to be doing lesson 14. And what we're going to be working on today is we're going to be finding areas by decomposing into rectangles, or we're going to be completing what's called the composite figures to form rectangles. So we're going to be kind of working in a couple different ways to find the areas of rectangles today. So when you are learning along with this lesson today, if you do have your personal whiteboard or a whiteboard at home, grab that and a marker. If you don't have them, just get a paper and pencil, and that works perfectly to have as a workspace. Even inside your math books, there are some pages that have been left blank, so you can easily use one of those too if you don't have any blank paper left. And then you're going to need your math books and obviously a pencil to be doing your work. So if you don't have those materials in front of you right now, go ahead and pause the video and go grab them and come on back. All right, to start off, we're going to do some skip counting. So what I want you to do is on your whiteboard or on your paper, go ahead and list your skip counts of 4s, 5s, 6s, and 9s. We want to make sure your fact fluency is still just as great as it has been. So go ahead and pause the video now to list them out. You can always sing those songs that you have in your head while you're listing them. All right, go ahead and do that now. Once you've listed them all, then click play and come to the next slide to check your work. All right, time to check our work. For 4s, it goes 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. So check that you had all those correct. And 5s, we have 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Next is 6s, and I bet a lot of you were singing that 6s song in your head while you did it. 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. And then 9s. We have 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. So check that you have all those skip counts correct. You can always practice them again if you need to refresh your memory on any of them. All right, next we have our application problem. I'm going to move myself up here. So for our application problem today, what you have to do is, went to the answers. You need to take this rectangle down here and you need to break apart that shaded figure into 2 rectangles to find the area of just that shaded portion. So you don't want to include this place here. You want to just think of how you can break apart this shaded region into 2 different rectangles. Since the shaded region is not a rectangle itself, it's kind of an L shape. You need to think about how you can break that figure up into 2 rectangles in order to find the area of just the shaded portion. So that's part A that you're going to work on your personal whiteboards first. So why don't you pause the video and go work on that. You can be drawing this out on your personal whiteboard if you have it, drawing this out on your piece of paper, or in a blank space in your book. But go ahead and use that image to find the area of just the shaded region by dividing it into 2 rectangles. Okay, now that you've done part A, do part B. And what you need to do for part B is you need to subtract the area of this unshaded rectangle from the area of the large rectangle. And you're going to do that to check your answer, because what you should get as your answer for part B should be the exact same answer that you get for A. This is just using 2 different ways to find that area of that irregular non-rectangular shape that's shaded. So we could do it like we did in part A by breaking it into 2 rectangles, Or this second way that I want you to do now with part B is find the area of this large rectangle, and you're going to take the area of this large rectangle and you're going to subtract the area of this white rectangle right there. So go ahead and do that now, and you should get the exact same answer you did for part A. So pause the video and go do part B. All right, to check our work here. So your sketches might look very similar to this when you sketched this out yourself. And the way you can break this rectangle up is by taking and doing, trying to use the technology here, is if you were to take and break this rectangle up here, so it was a 4x3 rectangle. So you kind of divided it right here. So you had a 4x3 rectangle, and you find the area of that 4x3 rectangle, which is 12 square units because 4 times 3 equals 12. So that's the area of that taller rectangle. Then the second rectangle that you would have had would be what's left here, this 2x2, which is actually a square, but this 2x2 rectangle here is the other part of the shaded region. And to find that area, you do length times width, 2 times 2, and you get 4 square units. So you're going to take your 12 square unit area of this rectangle, the 4 square unit area of this rectangle, and you're going to add those two together, which you'll get 12 plus 4 equals 16 square units, and that's the total area of your shaded shape. So that was part A. So the answer for part A is 16 square units when we solve it this way. Now for part B, what they wanted you to do is to think about the big rectangle here, which the dimensions of your big rectangle is 4 this way and 5 this way. So if you had 4 units by 5 units, to find the area of the large rectangle, you're going to do 4 times 5, which gets you 20. Whoops, and we forgot our label there. It should say 20 square units. So even us teachers make mistakes, so hopefully you caught that too. So 20 square units is the area of that large rectangle. Now we need to subtract the area of this white unshaded rectangle, which we can see by the dimensions of those units alongside it is a 2 by 2 rectangle. So 2 by 2, that area would be 4 square units because I take my length times width, 2 times 2, and get an area of 4 square units for this smaller rectangle. So I'm going to take the area of my large rectangle, which is 20 square units, subtract the area of my small rectangle, which is 4 square units, and 20 minus 4 gives me 16 square units. And then I noticed here that my answer for part A is the exact same as what I got for my answer in part B. So I know that my answer is correct because I got 16 square units on both part A and part B. So by solving the area 2 different ways, I was able to check my work and ensure that I am 100% correct. Okay, so like we just talked about on this slide when we were doing our application problem, is that in our last lesson, lesson 13, when Miss Quinn taught you that one last week, we learned that there are 2 different strategies to find the area of those non-rectangular shapes. So those shapes like what we just saw, that was like an L shape, something that's not a perfect rectangle. There are 2 different ways. The first way is to break the shape apart into 2 smaller rectangles and then add those areas together. That's what we did in part A of our application problem just now. We took and found 2 smaller rectangles within that shape, and we found the area of each of those and then added them together. Or the other way you could do it is like what we did in part B. You find the area of that larger rectangle, and then you subtract the area of that unknown part, that not shaded part. And then you'll be left with the area of the shaded shape. So those are the 2 ways, and we're going to be practicing those 2 ways today. So if you don't have your math book in front of you right now, quick pause this video and I need you to go grab that book and a pencil or something to write with so that way you can be practicing and doing this work along with me. So pause the video now, go grab your stuff if you don't already have it. If you do have it, perfect. Then let's get going. So you're going to turn to page 69 in your math book, and this is for lesson 14, problem set. So grade 3, module 4, lesson 14. So that's where you should be on page 69 right now. And we're going to do problem 1. We always read those directions first. So it says, find the area of each of the following figures. All figures are made up of rectangles. So I notice that my entire shape here, this entire shaded region, that's not a perfect rectangle. It's kind of like an upside down L shape now. But they have that little dotted line there to show me that it's actually made up of 2 rectangles. So what I can very easily do is find the area of each individual rectangle and then add them together. So I can use that strategy like I did in part A on my application problem to complete problem 1A in my problem set. So what I'm going to do is I am going to pop over to my document camera, and I'm going to do this along with you guys. So we should be looking at this now. Okay, so I see that I have, sorry, I just need to move my stuff here to be able to do this along with you, working with some limited space. So what I am going to do is I'm going to look at my shape, and I see that this dimension is 2 centimeters, and I see that this dimension here is 3 centimeters. They're telling me the full length this way of the entire shape. We have 2 centimeters to here and then 3 centimeters here. So if I take and I add the 2 centimeters plus 3 centimeters, how long is that dimension going to be? I bet you might have said 5 centimeters. And that is correct, because we know that if it's 5 centimeters across this way, the top length is the exact same, and it's going to be 5 centimeters as well. So now I know both my length and my width for this top rectangle. And I'm actually going to say that this one's going to be my rectangle A. So I'm going to now solve for the area of rectangle A over here. I'm going to take 2 centimeters multiplied by 5 centimeters, my length times my width, and 2 times 5. 2 times 5 is 10 square centimeters. Area always has square centimeters as our label. So I know that the area of this top rectangle that I called rectangle A, it has an area of 10 square centimeters. Now I need to go ahead and solve for the area of this rectangle down here. I see that this rectangle has one dimension of 3 centimeters and another one of 3 centimeters, because this 2 centimeters, that's outside that bottom rectangle. So I'm only looking at the dimensions of this one. So now to solve for the area of that, I'm going to do my length times my width again. 3 centimeters times 3 centimeters. 3 times 3. I'm going to go 3, 6, 9. So 9 square centimeters is the area of my bottom rectangle. So the area of this one equals 9 square centimeters. Now I'm not done, because I found this individual area and this individual area, but they want to know the total area for this entire figure. So how do I find the total area? Think about what operation I might do to find the total area when I have the 2 partial areas. I'm going to add them together. I'm going to take 10 square centimeters and add to it 9 square centimeters, lining up my place value columns so perfectly and my labels, and I get 10 plus 9 is 19 square centimeters. So that's what I know is the total area is 19 square centimeters. So if you didn't fill this out while you worked along with me, why don't you pause the video right now and fill this out in your books for number 1A on page 69 and fill that out. And then once you've done that along with me, then come back and we're going to do problem number 2 together down at the bottom of page 69. So pause it now if you need to finish filling this one out. Okay, now that you have finished 1A, we're going to go down to problem 2. Now, this figure looks a little different than the one that we just worked on up top. So this figure below shows a small rectangle inside a big rectangle. And they want us to find the area of the shaded part of the figure. So I'm going to think about my 2 strategies that I know I can use to find area. Just like we talked about before, I can either make it into smaller rectangles, find those areas, then add them together, or I could find the area of the large rectangle and subtract from it the area of that unknown part. Now, when I'm thinking of which way, which way makes the most sense, that second one makes the most sense. So like what I did on part B of my application problem, because it would be a lot harder to divide this shaded region up into separate rectangles based on the dimensions that I have right now. So what I'm going to do is I'm going to think about finding the area of my larger rectangle first, then the area of this white rectangle, the non-shaded rectangle, and then I'll subtract that smaller rectangle from the total area to be left with the shaded region. Okay, so to find the area of our larger rectangle, I'm going to look at the length and the width of the entire big rectangle. So I see 5 meters by 6 meters. So to find area, length times width. 5 meters times 6 meters equals, I could either skip count by my 5s or skip count by 6s and sing my song to find the total area for this one. I think I'm going to sing. So, oh, I think that I found a way to count by 6, 12, 18, 24, 30. So, oops, and I made a mistake on my label here. This one's not centimeters. This one's meters. So 30 square meters. I wonder how many of you caught my mistake there and were yelling at your computer screen saying, Miss Foley, fix that. Okay, so 5 meters times 6 meters equals 30 square meters. So that's the area of my large rectangle. Now I need to find the area of this white rectangle. So I need to think about the dimensions of this smaller rectangle. So let's see. I know that this whole length or width here is 5 meters. And then I have 1 meter here, 2 meters here. So if I've already used 1 meter and 2 meters, that's already 3 meters. That means what's left over for this direction is 2 meters. So one of the dimensions of this smaller rectangle is 2 meters. Now I need to figure out what it is this way. So I know my total is 6. I've used 2 here and 1 here. So 6 minus 3 leaves me with 3 meters this way. So my dimensions that I'm multiplying for this smaller rectangle are 2 meters times 3 meters, and 2 meters times 3 meters, 2 times 3 is 6 square meters. So I found the total area of that large rectangle. I found the area of this blank, unshaded region. I'm now going to take and subtract that smaller rectangle from the big one, and that'll leave me with what the shaded region is. 30 minus 6. I'm going to pop my labels on there. And I'm going to be thinking of my thumb checks as I subtract along the way. 0 minus 6. I see more on the floor here. So when there's more on the floor, I need to go next door and get 10 more. So that 3 becomes a 2. 0 becomes a 10. Now there's more on the top. No need to stop. 10 minus 6 is 4. And 2 minus nothing, well, 2 minus nothing is 2. I'm going to bring my labels straight down. And I'm left with 24 square meters. So that means the area of the shaded part is 24 square meters. Running out of space here. All right. If you didn't write this in your books along with me, pause the video now. Go ahead and do that and make sure you're completing this work along with me so that way you're understanding how to do it. It's great to watch a teacher do it, but to actually do it yourself is when you really learn it and it really clicks. So pause the video and go do that now. Okay, so now that we have done a couple practice problems together, let me just get myself back into the Google Slides here. Okay, so now that we have done those together, what you're going to go off and do now is you're going to go on to Zern and you're going to complete lesson 14 only. So I know some of you, when you were working last week on Zern, some of you got so excited and you got ahead. So some of you, when you log into your Zern, it may say that you already are on lesson 14 or you've already done 14 and maybe you're on 15. So check what number it says when you're on Zern. And if you're not sure, you can send an email to one of your teachers or message them in Google Classroom and they can let you know what problem or what lesson you're on. So that way you don't get too far ahead. We want you to be right where we are. So if you haven't already, complete only lesson 14. Don't go past 14 in Zern. Then once you do that, go back and complete the rest of your problem set pages. So that's the rest of page 69. We only did one A and B, or sorry, we only did one A and 2. You still have one B left. And then on page 70, you have numbers 3 and 4. So go ahead and do those. And then also go into the Google Classroom where you found this video in your lessons for this week. And you're going to complete the must do lesson 14 assignment. And you're going to click the turn in button on Google Classroom when you have completed it. So that way we can check your work since we can't be at your house to look at your books from there. So we want to be able to see the work that you're doing by you going and completing that must do lesson 14 assignment and clicking the turn in button. So on the next slide, is the answers to your problem set. So once you complete your problem set pages, come back to this video and check your work. Don't just go look at those answers now. I know some of you might be sneaking in doing that, but that's not how it works. You got to do the work first, then come back and then check your answers. So if you have not completed the rest of your problem set pages yet, pause the video, go work on them, and then come back and you can check your answers on the next page. But if you have already done that, then you can just come right next to this next slide with me and we can check your work. So either head off to go do Zern or work on your problem set, or if you're tuning back in to check your answers, let's go check them out. Okay, let me move myself where I'm not going to get in the way of anything. All right, so here are the answers to check your work. Like I said earlier, we already did 1A and number 2 together. So those answers you should have correct because we did them together. You'll see 1B, 3, and 4 here for you to be doing your checking of your work with. If you have any questions on any of these, shoot one of your teachers an email, tune in during our office hours, and we will absolutely help you. We are here to make sure that this process isn't super confusing and that you're still feeling just as successful as you do in the classroom. So make sure to ask someone for help if you're needing it. And thanks for being in lesson 14 math lesson with me today. It was really fun to be able to still be teaching you, but I do miss seeing you all in the classroom. So I cannot wait to see you soon, and I will see you at office hours and morning meetings and chat with you via email the rest of this week. Good luck with your work.